Hello, I'm Stuart Williams, and here I'm going to give you an introduction to some aspects of microfluidic experiments, more specifically how to make connections for microfluidic electrokinetic chips like dielectrophoresis. We do a lot of dielectrophoresis and other electrokinetics in our lab. So making a connection. There's several ways that you can do this. I'm going to go over some of the techniques that we use in our lab. That includes using copper tape, conductive epoxy, or mini card holders. And I have a few examples here that I'm going to show you. So the first is copper tape. So copper tape is relatively inexpensive, and the advantage here is it has some adhesive on the back side of it. Now, with the adhesive that's on the back side, this adhesive is typically not electrically conductive. So let's say you lay this or tape this on top of a piece, you might be able to get an electrical connection as the metal could penetrate through the underlying adhesive and make an electrical connection on the back side. So here is an example. So an example here is a large, broad, gold-plated glass slide, and we have our copper tape on it, and this does indeed make an electrical connection. In this case, I'm sorry, I'll flip it. The gold's actually on this side, so pardon that. But this makes an electrical connection. You can see some scratch marks here because we applied some pressure. But sometimes this is not a guarantee in terms of the metal going through the adhesive of the tape. So in this case, we actually also applied a little bit of conductive epoxy to make an electrical connection between the copper here, and it bled over onto the gold down here. So the conductive epoxy here is used to supplement and make sure that there is a connection here. And we do that. You might have also noticed that on our, these are indium tin coated cover slips. So we have conductive epoxy here that helps ensure that this copper tape makes an electrical connection with the indium tin oxide coating here. Now, advantage of using the copper tape is that you can then solder wires to it. You could clip onto the copper tape directly, but in this case, we solder on the copper tape little wires, and then those can move on. So I'll go ahead and I'll skip over to the conductive epoxy. If you've not used it before, it is typically mix 2 parts, and then you wait typically 24 hours at room temperature, or if you heat it to about 60 degrees Celsius or 80 degrees Celsius, it can cure much faster, maybe within a couple hours. But of course, read the manufacturers. There's some slight variations between them, but usually you mix part 50-50 of part 1 and another part, mix it, and then apply it. And that's what we've done here. But you can also apply it directly to your electrodes on your chip, and then you can use little wires to complete that connection. But one thing I will say is that the conductive epoxy itself is not an extremely good with respect to strength. It's good at the electrical conduction, but with respect to strength, sometimes the wires, if you pull hard enough, will peel off the conductive epoxy. So sometimes what I do is that we apply a 5-minute epoxy on top of the conductive epoxy just to give it some additional strength. So if you're going to be handling your chip multiple times or cleaning it and reusing it, this just helps make sure that the wire connection, so as an example, if you had a wire connected to a chip via conductive epoxy, I recommend applying this on. Now this is not electrically conductive, so this can bleed over. You can be a little more generous with this. So this is not electrically conductive, and it helps with making sure that the wire stays connected if you use conductive epoxy to connect a wire. And then the last example that I'm going to go over is what if you had a lot of connections. So this is a chip with some glass, some electrodes on glass with all these different connections here. So making individual connections here with wires and conductive epoxy can be taxing because you have just so many connections to make, and you could bleed over on the conductive epoxy. It just becomes difficult. So what we do in this instance is that you can get a mini edge card holder, and you can find these. We like to use Samtech. They're local. You can also sometimes get free samples from them. So we only need a few of these. And make sure you design your chip to fit within the slot that you need, as well as the electrode spacing that is required here. And then also the thickness of your slot right here. Because whether you're using a silicon wafer or a glass wafer or a glass slide, whatever you may be using, make sure it fits within here as well if you're going to go through this approach. So these are the approaches that we typically use in our lab. And there are a few others that we have used in the past. So one is using a pin to have in direct contact, to come in direct contact with your chip. But this is a pogo pin. So a pogo pin has some flexibility here on the tip, and then there's a spring there that will help push this in like that when it comes in contact with your chip. So that is a pogo pin, and you can arrange these either on a circuit board or however based on your geometry, and then make some type of sandwiching or clamping device to make that connection. And then here is one that you could also use. This one's also from Samtech, where there's these spring-like edges here that will compress when you slide in. So this one, you could, with these fasteners here, you could, in theory, take a fastener and then apply this to your chip. Like, it can come straight down and you can make your connections and have multiple contacts with that. So this just gives some insight into some additional techniques that we use in our lab to help make connections. And if you have additional questions, feel free to email me or visit our website, and thank you for paying attention.